The inspector is correct in citing Table 310.15b2, which derates current carrying conductors when installed in conduit with more than 3 current carrying conductors. Based on this derating, only 9 number 12 conductors can be installed in a 1-inch conduit if the conductors are protected by 20 amp breakers and the minimum load is not present. Running 12 number 12 conductors in a 1-inch conduit is not uncommon in practice, especially for low-load applications like computer equipment. While the inspector's interpretation is technically correct, many electricians argue that the derating is overly conservative for small diameter conduits and loads that are well below the breaker rating. The minimum load condition is not always present in real-world scenarios, especially for intermittently used equipment like computers. There are possible compromises to consider. Firstly, reinstall with a larger conduit. This would ensure compliance with the derating table but increase the cost and labor involved. Secondly, use a different conductor size. Using number 10 or number 14 conductors would allow for more conductors in the conduit without needing to derate. Thirdly, negotiate with the inspector. Explain the technical details of the load and argue for a deviation from the strict interpretation of the code. Most inspectors are willing to consider reasonable exceptions. Ultimately, the best course of action depends on the specific circumstances and the inspector's interpretation. If a compromise cannot be reached, it may be necessary to comply with the code as written and install a larger conduit or use different conductor sizes. However, it's important to note that the derating requirement is generally not strictly enforced for small diameter conduits and low-load applications. Let's delve deeper into the specifics. Table 310.15b2 of the National Electrical Code, (NEC), addresses the ampacity derating of conductors in a raceway or cable. This section requires ampacity adjustment factors when the number of current carrying conductors in a raceway or cable exceeds 3. The purpose of this derating is to prevent overheating of the conductors due to the cumulative heat generated by multiple conductors in close proximity. The table provides adjustment factors that reduce the allowable ampacity of the conductors based on the number of current carrying conductors. For example, if there are 4 to 6 current carrying conductors, the ampacity must be derated to 80% of its original value. For 7 to 9 conductors, the ampacity must be derated to 70%. For 10 to 20 conductors, it drops to 50%, and so on. In a scenario presented, there are 12 current carrying conductors in a single conduit. According to Table 310.15b2, the ampacity of these conductors must be derated to 50% of their original value. Number 12 AWG copper conductors, commonly used for 20 amp circuits, typically have an ampacity of 30 amps according to Table 310.16 of the NEC, assuming they are insulated with a common insulation type like THHN or THWN and are operating at an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit. After applying the 50% derating factor, the allowable ampacity of each number 12 conductor is reduced to 15 amps. This is calculated by multiplying 30 amps by 0.50, which equals 15 amps. Since the computer equipment only draws 2 amps on each circuit, the electrician might argue that the derating is unnecessary because the conductors are not being loaded to their full capacity. However, the NEC requires that the conductors be protected by an overcurrent device such as a circuit breaker that is sized appropriately for the conductor's ampacity. In this case, the conductors are protected by 20 amp breakers. Even though the actual load is only 2 amps, the conductors must be able to safely carry the full 20 amps that the breaker could potentially allow. Since the derated ampacity of the number 12 conductors is only 15 amps, they are not adequately protected by the 20 amp breakers. This is why the inspector cited the NEC violation. From the electrician's perspective, the derating requirements can be overly conservative, especially in situations where the actual load is significantly lower than the conductor's ampacity. They might argue that the derating is intended to prevent overheating under full load conditions, and since the computer equipment only draws 2 amps, the conductors will not overheat even with 12 conductors in the conduit. Additionally, the electrician might point out that the derating factors in Table 310.15b2 are based on worst-case scenarios and do not take into account factors such as the type of conduit, the ambient temperature, and the ventilation of the conduit. In some cases, these factors can significantly reduce the temperature rise of the conductors and make the derating unnecessary. Despite these arguments, the inspector is responsible for enforcing the NEC as it is written. Unless the electrician can provide documentation or calculations that demonstrate that the conductors will not overheat under the specific conditions of the installation, the inspector is likely to require that the electrician comply with the derating requirements. There are several possible solutions to this problem. Firstly, the electrician could replace the 1-inch conduit with a larger conduit that can accommodate all 12 conductors without derating. Table C1 in Annex C of the NEC provides information on the maximum number of conductors that can be installed in different sizes of conduit. For example, a 1/4-inch conduit might be large enough to accommodate 12 number 12 conductors without derating, depending on the type of insulation. Secondly, the electrician could reduce the number of conductors in the conduit by splitting the circuits into multiple conduits. For example, they could run 2 conduits with 6 conductors each. This would reduce the derating factor to 80%, which might be acceptable depending on the ampacity of the conductors and the size of the breakers. Thirdly, the electrician could use larger conductors with a higher ampacity. For example, they could replace the number 12 conductors with number 10 conductors, which typically have an ampacity of 35 amps. After applying the 50% derating factor, the allowable ampacity of the number 10 conductors would be 17.5 amps, which is still not sufficient to be protected by 20 amp breakers. They could use number 8 conductors, which have an ampacity of 50 amps. After derating to 50%, this would allow them to be used with 20 amp breakers. However, using larger conductors would increase the cost of the installation. Fourthly, the electrician could use a different type of conductor with a higher temperature rating. For example, they could use THHN conductors with a 90°C rating. This would increase the ampacity of the conductors and reduce the amount of derating required. However, the terminals on the equipment and the breakers must also be rated for 90°C for this to be a viable solution. Fifthly, the electrician could install a separate conduit for each circuit. This would eliminate the need for derating altogether, but it would also be the most expensive and time-consuming solution. Finally, the electrician could try to negotiate with the inspector. They could explain the specific details of the installation, such as the low load on each circuit and the type of conduit being used. They could also provide calculations or documentation to support their argument that the conductors will not overheat. The inspector might be willing to grant a variance or exception to the code if they are convinced that the installation is safe. However, it is important to remember that the inspector has the final say in whether or not the installation complies with the code. In addition to the NEC requirements, there may also be local codes or regulations that apply to the installation. The electrician should check with the local building department to ensure that they are in compliance with all applicable codes and regulations. The NEC is updated every 3 years, so it is important to stay up to date on the latest changes. The NEC is a complex document, and it is important to have a thorough understanding of its requirements before performing any electrical work. It is also important to consult with a qualified electrician or electrical engineer if you have any questions or concerns about the code. Here are some additional points to consider. The NEC does allow for some exceptions to the derating requirements in certain situations. For example, Section 310.15b3 allows the ampacity of conductors to be increased under certain conditions, such as when the conductors are installed in free air or when they are part of a manufactured cable assembly. However, these exceptions are typically only applicable in specific situations and may not apply to the scenario presented. The NEC also provides some guidance on how to calculate the ampacity of conductors in different situations. For example, Section 310.15c provides formulas for calculating the ampacity of conductors in underground installations. These formulas take into account factors such as the thermal resistivity of the soil and the depth of the installation. The NEC is not intended to be a substitute for sound engineering judgment. Electrical installation should be designed and installed by qualified professionals who have a thorough understanding of the code and the principles of electrical engineering. The NEC is a living document, and it is constantly being revised and updated to reflect changes in technology and industry practices. It is important to stay informed about the latest changes to the code so that you can ensure that your electrical installations are safe and compliant. Remember to consult the latest edition of the NEC and any applicable local codes or regulations for the most accurate and up-to-date information. The NEC is a comprehensive set of guidelines for electrical safety, and adhering to its requirements is crucial for ensuring the safety of people and property. It is a collaborative effort between electricians, inspectors, engineers, and other stakeholders to develop and maintain these standards. The ultimate goal is to prevent electrical hazards and ensure that electrical systems are installed and operated in a safe and reliable manner. The specific application mentioned, supplying computer equipment, is also important. Although computers typically draw low amperage, their power supplies can create harmonic currents which can increase the heat generated in the neutral conductor. If the neutral is counted as a current-carrying conductor, this can influence the Derating calculation. It's important to verify if the neutral needs to be counted. For typical single-phase circuits, the neutral is only counted as a current-carrying conductor when the majority of the load is nonlinear. With 12 current-carrying conductors, you need to consider the practical implications of working in a crowded conduit. Pulling conductors can be more difficult, and it can increase the risk of damage to the conductor insulation. Damaged insulation can create shorts, ground faults, and potential fire hazards. When considering derating, it is important to account for future load changes. Even if the current load is only 2 amps per circuit, there is always the possibility that the load will increase in the future. It is better to design the system for the maximum possible load rather than the current load to avoid having to make costly changes later. Finally, remember that the inspector's job is to ensure safety and compliance with the code. Even if you disagree with the inspector's interpretation, it is important to be respectful and professional. If you believe the inspector is incorrect, you can appeal their decision to a higher authority. However, it is important to have a solid understanding of the code and be able to support your argument with documentation and calculations. In conclusion, while the actual load may be low, the code requires that conductors be protected based on the potential to carry current as determined by the breaker size, and derating is necessary when multiple current-carrying conductors are present in a conduit. There are various options to address this, including using larger conduit, reducing the number of conductors in the conduit, using larger conductors, using conductors with a higher temperature rating, or negotiating with the inspector. Remember to consult the latest edition of the NEC and local codes for specific requirements and to ensure safe and compliant electrical installation.